Today's lesson is proving triangles congruent by side, angle, side. Okay, my learning objective for today is I can prove two triangles are congruent with three corresponding parts by side, angle, side, triangle congruence. Let's start with some vocabulary. We have something called CPCTC, which represents corresponding parts of congruent triangles are congruent. So we've been working with corresponding triangles and corresponding polygons. For triangles, there are 6 pairs of corresponding parts, 3 pairs of angles, and 3 pairs of sides. So I don't need all 6 to prove that my triangles are congruent. I can prove with 3 pairs, but they have to be in a specific order. And one order is side, angle, side. So side, angle, side means I am talking about if 2 pairs of congruent sides and their included angle, so that's the angle between the 2 sides, then the triangles are congruent. So I know I'm between 2 angles, and I'm looking at sides for tick marks and shared sides. And angles, I'm looking for arc marks and vertical angles. So let's take a look. So I'm going to start out with, I'm going to talk about, one pair of congruent sides. So here's a side. Here is an angle. And here is my second side. So the angle has to be in between the 2 sides. All right, let's make sure we understand what an included angle and shared sides mean. So what is the included angle between segment LP and LK? So if I'm looking between LP and LK, so I'm going between these two, the included angle is going to be angle P. Between LP and LK. I put KP. Let's do the correct one. This is LK. All right. So the angle, the included angle is the angle between. So it's this angle here. I cannot just call it angle L because I have more than one angle L. So I have to use 3 letters. So I can either call this angle KLP, or I can call it angle PLK. So L is the vertex, the middle letter. Let's try the included angle between KL. So I have KL again, and JL. And JL here. So this I'm going to make this angle, so the other angle L. So I need to, again, name it with 3 letters, so I can call it JLK. So angle JLK, or angle KLJ, or angle KLJ. Okay, I can share sides. I am asking, what is the triangle? What side am I sharing between triangle JKL? So between my 2 triangles, the side that I'm sharing is right here. So this is my side that I'm sharing, which is a segment, and it's called KL. Okay, so when I am using side angle side triangle congruence, if this is my angle, these are the side angle side that I need. If this would be my angle, these would be side angle side. Or if this is my angle, side angle side. So they are in a row, okay? They're consecutive. Okay, let's do a proof. Write a proof. We're given that segment BC is congruent to segment DA. Segment BC is parallel to segment AD, and prove that triangle ABC is congruent to triangle CDA. Okay, so let's set up. We're going to set up all our information the way we normally do. So given, my given information, I have two pieces of given information. So the reasons for the given information are given. So I am given that segment BC is congruent to segment DA, and segment BC is parallel to segment AD. I am doing the proving, so I never write that, and I'm trying to prove that triangle ABC is congruent to triangle CDA. So I put that as my last statement. So let's start putting some information in here. So I'm going to start with, I see that I am sharing a side here. So anytime I'm sharing a side, I can say segment AC is congruent with segment AC. And this is called the reflexive property of congruence. Okay. And then since I have some parallel lines here, I know BCA, so I know this angle is congruent to this angle because these are parallel lines, and when we had parallel lines, my alternate interior angles are congruent. So I am going to say this is angle BCA. So angle BCA is congruent to triangle CAD. And I'm doing that because I know alternate interior angles are congruent. So now I'm looking at, I see that I have a side. So my side, here's one of my sides. Then I have an angle. Here's an angle. And then here's my second side. So I have side angle side, so I can say that my two triangles are congruent by side angle side congruence. Okay, let's apply these properties on a circle. So in the diagram, segment QS and RP pass through the center M of the circle. Can you conclude that triangle MRS is congruent to triangle MPQ? So I want to know, are my two triangles congruent? And I can state they are congruent if I know all 6 parts are congruent, or if I have three parts in a specific order, the side, angle, side. All right, so what do I know about the angles? I know that I have some vertical angles right here, and all these vertical angles are congruent. So I'm going to name them as angle SMR, angle SMR is congruent to angle PQR. And I can state that because these are vertical angles. So vertical angles are always congruent. So what do I know about sides? So I can say that I know that all of these sides are congruent, and I know that because that is the radius of the circle. So I can say segment SM is congruent to segment MR, and that's congruent to segment MP, and that's congruent to segment MQ. And I'm saying that because all radii are congruent. And radii is plural for radius. So in a circle, okay. So now if I'm looking, I have side, angle, side. Do you see how I have that? Side, angle, side. So I can say, yes, these are triangles are congruent by side, angle, side congruence. Got it.